sorry that last one cut off so abruptly. My phone rang, and anyway, sorry about that. I basically finished my thought though. The only thing I wanted to add about this is that you can find these on page 121 in your book. Again, I can't stress enough how important it is that you memorize this top one. You're going to see it over and over and over. All right, so next of all, I did this already, I proved this one. Okay, so use a special product pattern to evaluate this expression. Okay, so we've got 4n plus 5 times 4n minus 5. They are identical, except one's a plus and one's a minus. So remember that one I told you to memorize? What's nice about this is you don't have to FOIL. You know what it is. It's the square of the first term minus the square of the second term. And that's it. That's how you know the answer. Okay. All right, now we're going to shift gears just a little bit and talk about Blaise Pascal. Look, here he is. I wonder if he had to sit still really long for them to paint him. I don't know. Anyway, here he is. He was alive between 1623 and 1662, so that's how old this information is. And quite frankly though, if you think about it and you think of the history of mathematics, it's actually pretty new. The 1600s were not that long ago when you're talking about 2000 BC with some of the mathematics that we have. So Pascal's triangle is a special pattern of coefficients named after Pascal. And I'm going to show you it, and you're going to love it because math is so groovy. All right, so Pascal's triangle. This is taking a binomial and expanding it, okay? So n tells us what the exponent is. Here's the binomial expansion, and then we're going to look at Pascal's triangle so that you can see how you can use that. Okay, so the first one, when n is 0, and I think that's one of the things that's a little bit confusing about Pascal's triangle is there is a 0th row. So you just don't start counting it when there's a 0th row. So when n is 0 and we have a plus b to the 0 power, anything to the 0 power is just 1. So we've got 1 right there. And that's the very top of Pascal's triangle. All right, so the next row is when n is 1, and that's just a plus b. And we expand that, and it's just a plus b. But we have these invisible ones. And we come over here to Pascal's triangle, and we put a 1 and a 1. And now this is where it gets fun. Okay, second row. This is when we have a plus b squared. And if you remember the special products, it was a squared plus 2ab plus b squared. Now they went ahead and put the invisible ones in there because that's the next row of Pascal's triangle. Okay, and what I want you to notice is that the ones just keep coming down like this, but in between each one of these, they add up. So let's look at the next row. So the third row, this would actually, it's the third row, it's the fourth one down. But a plus b to the third power, okay, this is a cubic, right? This is when it's cubed. We have a cubed plus 3a2, a squared b plus 3ab squared plus b to the third. Well, let's just look at the coefficients. So we have the ones that come down, and now look at this. We've got 1 plus 2 is 3, 2 plus 1 is 3. So hopefully you know what's next. If we were to multiply out a plus b to itself 4 times, we would get this polynomial. So also the first term starts off with the full exponent and it goes down. You know what, I'll show you all that in a second because it's a little tricky. But mostly what we're looking at here is the coefficients. So we have 1, 4, 6, 4, 1. And again, the ones come down. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. So what do you think? Oh, here's the next one. Okay, we're just adding up again. So if this is 0, 1, 2, 3, 4, 5. So if I want a plus b to the 6th power, what would it be? What would my coefficients be? Well, I would have 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. And then 6, and then 1. Okay, so that is Pascal's triangle. Let me erase it so you can see it a little bit better. Okay, but doing this, you could find, it would take a long time, but you could find the 50th row. And there's actually another way you can do it, but that's not something we're going to cover in this class. You can find it on page 123 in your book. All right, we're going to expand some binomials, and we're going to do that in the next video.